Hi everyone, my name is Azima binti Azmi and my matrix number is 2000855. So for the final assessment of PHY4301 microprocessor and microcontroller, I'll be explaining about 5 simple assembly language instructions. So on this video, I'll be explaining 5 instructions, which are MOV instructions, ADD instructions, SUB instructions, AND instructions, and shift right instructions. So let's proceed for the first one, which is the MOV instructions. The MOV instructions copies data from one location to another using this format: MOV destination, source, which means it will copy source operand to destination. For example, if you write MOV AX, BX, it will copy content of register BX to AX. The MOV instructions can be executed depends on, it has few conditions. The first one is the data can be moved along all registers except flag register. The second one, data can be moved directly into non-segment registers only. The third one, values cannot be loaded directly into any segment register such as CS, DS, ES or SS, which means we have to insert the values into non-segment register first, and then only we can instruct the non-segment register to the segment register. Last one is one cannot move the contents of a 16-bit register into an 8-bit register. So the table below shows the list of 16-bit register and 8-bit register. Let me show you the example on how the MOV instructions can be executed using the emulator 8086. So for this instruction, we type in MOVAL, 23 hexadecimal, MOVBL, AL, and MOVCL, BL. So when we execute the instruction, we can see that the BX and CX register copied the 23 hex in AX register. So for the second one is ADD instructions. ADD tells the CPU to add the source and destination operands and put the result in the destination. The format is ADD's destination, source, which means it will add up the source and the destination. 8-bit register can hold up only to FFH, which is 2 to 5 decimal. 2 to 5 in decimal form. So any number that is more than 2 to 5, we have to use the 16-bit register. The example for ADD instruction is as shown. So here's the example when I use emulator 8086. For ADD instruction, we type in MOV AX, 23H, MOVBX, 12H, and then we add ADD AX, BX to add up the two numbers. So after executing the instruction, we can see the result in binary, hexadecimal, and in decimal. Okay, next, for SUB instructions. SUB instructions is the subtraction instructions. It has similarities with the ADD instructions. SUB tells the CPU to subtract the source and destination operands and put the result in the destination. So the format is SUB destination, source, which means the destination will minus the source. After the execution, if if the carry flag equal to 0, the result is positive, and if the carry flag equal to 1, the result is negative. So here is the example on emulator 8086. For SUB instruction, let's say we take 3CH, which is 60 in decimal, minus with 11H, which is 17 in decimal. After executing, we can see that the result 60 minus 17 is 43 in decimal. Alright, next we'll proceed to the AND instructions. AND destination, the format is as below: AND destination, comma source, which means it will perform a logical AND on the source and place result in the destination. AND will automatically change CF, carry flag, and OF to 0. The PF, ZF, and SF are set according to result. So this table here shows it is the truth table for AND gate. Next, let me show you how the instruction is executed on emulator 8086. For AND instruction, we type in MOVBL, 35H and ANDBL, 0FH. So, in binary, when we perform logical AND instruction, we will get 00000101. So, for the final one, which is the shift right instructions. Shift right instruction is logical shift right. Source operand is shifted bit by bit in binary. For every shift, the least significant bit, LSB, will go to the carry flag, CF, and meanwhile, the most significant bit, MSB, is filled with 0. Next, I'll explain how it is executed on emulator 8086. So for this final instruction, which is shift right instruction, when we execute this instruction, we can see it at the binary part. So let's focus on the binary part. We can see that the value, the original value, is shifted bit by bit to the right. So that is all from me. That is my 5 simple assembly language instructions. Thank you.